What's going on, guys? Gas furnaces today. So we're gonna go over the sequence of operation. I'm gonna do a few tests for you to kind of prove some of the same things that I'm talking about. But yeah, let's dive into it. All right, so what I got set up here is I got my multimeter hooked up across that pressure switch in there. I also have my manometer hanging on the side over here, hooked in series with that pressure switch. It's hooked to right here on the inducer motor, so that's where we're reading our negative pressure draw off of the, make sure that this is actually pulling a negative pressure inside that heat exchanger, and we're going to see what that's pulling here. So remember the sequence of operation on these things, and there's always going to be a little bit of debate about what I'm about to say, but from the tests that I've done, it's the way that I go by. Call for heat from the thermostat. Number one, always number one. We can't do anything unless that thermostat's sane. So if that thermostat isn't saying anything, or it's off, and your furnace is trying to start up, well, you got a problem. Okay. Number two, as soon as we get a call for heat, the board inside this cabinet here is going to send 24 volts through the safety circuit, which includes this pressure switch. And that pressure switch needs to be open. If it is not open, nothing will happen past that. It needs to be open to start. As soon as it proves that it's open, this inducer motor will start up and start pulling a negative pressure on that heat exchanger. As soon as that happens, then this pressure switch needs to close based on the negative pressure that we're pulling in here. And every switch is going to be a little different. We'll zoom in here a little bit on this one. This one is saying it needs a negative 1.10 inches of water column pressure on it in order for this switch to close. So that's what the manufacturer has deemed is the proper vacuum to prove that this inducer motor is pulling enough of a negative pressure inside that heat exchanger that we're going to pull all that nasty stuff that we burn up and out the flue pipe. After this has come on and we have verified this is closed, after a small time delay, we'll get hot surface ignition. We'll let that heat up for a few seconds. Next, we'll get 24 volts to the gas valve, which will allow gas into the burners, and we should ignite the flame as long as that hot surface igniter is burning hot enough. As soon as we ignite the flame, our flame sensor that's back in there will sense that the flame is actually burning. It's a thermopile, so it will turn that heat signal from being sitting right in the flame, it turns it into a small DC electrical current that the board then reads. And then that's how we prove that the flame is burning, by the electrical current that it produces from the heat that the board receives. Once it proves that the flame is burning, the blower motor will come on, the board will leave this gas valve on, and will continue to burn the flame. So let's do a few tests here. Right now, like I said, I have my multimeter hooked across that switch. And a couple of things that will keep that switch from closing are, number one, our inducer motor flat just doesn't work. Okay? But number two, and usually more common, is we actually have a plug or something blocking either this exhaust pipe or this intake pipe, okay, or something actually inside the inducer here that's blocking airflow from going. So what I've done here is I've actually separated the exhaust pipe from the inducer motor, and I've stuck a piece of cardboard in between there. So basically what happens is this inducer is going to start up, but nothing's going to be able to leave. I'm simulating that there's a blockage in this inducer housing. Okay, and we're going to see what happens. So I'm going to do step number one. I'm going to come over here and give us a call for heat. Okay. And of course my probe fell out. We have an open switch. Yes, the inducer motor is running, but we are not pulling the proper vacuum. We're not pulling any vacuum at all, really. We needed 1.1 inches of water column, negative pressure, in order for that switch to close. So that switch is operating properly, and nothing wrong with that switch. We're not pulling the proper vacuum. But what I've done is I've blocked it. So the furnace will not continue in its process until we clear the blockage, until we can prove that this inducer motor is running by closing that switch. Okay, I've removed the blockage, my piece of cardboard, and we'll fire this thing back up and see what happens now. Call for heat. Come on. Inducer started up. We've verified this was open. The inducer started. It's now closed. My probes aren't in there very tight, so we have a little bit of voltage there, but I am now pulling a proper vacuum, way over what I need, which is just fine, but I have at least 1.1 inches of water column on my negative probe. There goes our hot surface ignition. Gas valve, flame. After a few seconds, we're sensing that there's a flame with our flame sensor. Board is satisfied with the flame sense that we're getting. It's keeping the gas valve on. Blower motor will start up after the heat exchanger gets to a certain temperature. Sequence of operation. And there goes the blower motor. Now let's test what I said before about call for heat and then check if the switch is open. There's always a lot of debate about that, but we're going to talk about it right now. Okay. So I've removed my probes from my multimeter and I've replaced them with a jumper wire. That's just going from one side of that switch to the other. So when I put a call for heat, and this board then sends 24 volts through all these safeties to verify that they are closed, and in this case open. It wants to verify that this switch is open. Then it will bring on the inducer. I've had guys tell me, no, it's just a call for heat, then the inducer comes on, and then that switch closes. Well, what if that switch stuck closed the last time that this furnace fired up? And it's still passing that 24 volts as if this inducer was running. Now the likelihood of this sticking closed and the inducer motor flat out not working on the next startup is very remote, but the possibility is there, especially on older equipment. So if this stuck closed the last time this furnace shut off, didn't open back up, and then there is a problem with this, and this doesn't start, well, we'll continue through the sequence of operation because this is stuck closed, telling the control board that, yep, the inducer's running, even though it's not. We turn the gas valve on, we ignite the gas, we're burning gas, but we're not getting rid of any of the combustibles that we're creating in that gas chamber. and we create a dangerous situation. This board is going to verify that this switch is open first, to verify that that switch is actually operating correctly, and then it will start the inducer. And then if everything is running correctly, this inducer will pull enough of a vacuum on this switch, then that switch will close and will continue the process. So let's test it out. Right now I got the jumper wires on there. So basically what I'm doing is I'm bypassing that switch. The board is going to think that that switch is closed right at the start. I'm just jumping the 24 volts from one terminal right to the other as if the switch was closed. Let's see what happens. Call for heat. No inducer motor, but the blower motor started up. Now in most furnaces, whenever there's a malfunctioning safety switch, the board automatically brings the blower motor on just in case we have an overheating type of situation. It brings the blower on for safety to try to cool the heat exchanger down. It doesn't know what's really going on, it just knows that one of the safeties is open. So it automatically brings on the blower motor. There's my call for heat, but no inducer motor. Because the board has noticed that this switch is closed, is passing 24 volts through that switch. It's not going to go any farther. It needs to verify that that switch is open and not stuck before it will start the inducer and continue the process. Call for heat. No inducer motor, but the blower motor came on. Now let's see what happens as soon as I pull this, when I pull this switch off, or this jump wire, because that switch is technically open, I'm just bypassing it by jumping it across. Let's see what happens. Well, what do you know? Now the board has verified that it opened, now it will continue the process. Start the inducer. Switch is closed. I can verify that by my thing zeroed out. 1 second. Well, that was bad TV. No, I just had my thing zeroed out on me, so I had to zero it back out. Pulling plenty of vacuum on that switch. Then we're going through the process. Hot surface ignition. Flame. 24 volts to the gas valve, which creates the flame. And we are verifying flame with the flame sensor. Gas valve will stay on. Blower motor. Let's go over it again. Call for heat. Furnace control board will verify that that pressure switch and the other pressure switch, which we haven't talked much about, but this is a 90% furnace. Okay, so we're going to condensate. So that one is actually hooked to down there at the bottom of the collector box, which if we get water's draining out of there. If we get a plug and water starts to pile up, we won't be able to pull a vacuum through that hose, and this switch will open up and cut power. So we got call for heat. Furnace board verifies that the inducer switch is open. Then it brings on the inducer. If the inducer pulls the proper vacuum, meaning all vents are clear and the inducer motor runs good, the switch will close. We will initiate hot surface ignition. It will glow red and warm up. As soon as it gets to a proper temperature, we'll energize the gas valve, which will then pump gas into our chamber. We should ignite. And then our flame sensor, which is way back there in the back, focus on just a little bit, there it is going to verify that our flame is burning. As soon as all those are proven, the blower motor will come on after the heat exchanger heats to a certain temperature, and we will resume normal operation until the thermostat is satisfied and kills the call for heat. Operation again is thermostat, verify that pressure switch is open, inducer motor starts, pressure switch will close on vacuum from the inducer motor, hot surface ignition will proceed, it will warm up, 24 volts will be given to the gas valve, gas will pump into the burner chamber and ignite, and our flame sensor will sense flame, our blower motor will fire up. And we're heating. Thanks guys. See you on the next one.